And this step is for VN configuration. Okay, VN is short for virtual networks. And under this step, we are going to create 3 different virtual networks and configure mutual access between different VNs. 2 steps. The first one, create virtual networks. Let's go to the AC 3.0 and move to provision logic network. And by default, on this page, you can just see the default VN. Okay, that's created by default. And that's because I have already created 3 different virtual networks so that you can see this 3 but by default, you cannot see them. You have to create each of the VN one by one. Okay, let's see the OA VN. For you, you can click this one and you can see the page that you have to fill in the blanks. And let's move to the OA network. Okay, and also for all of these parameters, all of these IP address or VLAN IDs, you can follow the guide. Okay, follow the data planning, the documentation. And then for the first one, for the first VN, name the external network, the network service resources, every single parameter we have the information list here. Okay, let's see each of the information one by one, the name and the technology that we use to create the virtual network, VXLAN. We only have one choice. Okay. In a second, the service gateway inside of the fabric or outside of the fabric. Because in this example, we want the aggregation switch, I mean the edge devices to perform the layer 3 gateway of the users. So we choose the inside fabric. And for the external network, do you remember that we have already defined 3 different external network, right? So for the OA, I'm going to choose the OA external network. Now for the network service resources, we have already created one named service. Okay, so we choose this one. And this one can be shared between different virtual networks. For the IP subnets using by the end systems or using by the stations, we can define them here. Okay, we can use the automatic allocation. If you want to create 10 IP subnets, you can input the quantity 10 here. In this case, we just create 2 IP subnet in one time. Okay, for this page, you can create multiple IP subnet in one time or one page. Okay, for now we just create 2, and you can create IPv4 or or IPv6 IP subnet. Okay, and in this case, let's go to the data planning. As you can see, that I am going to create 2 IP subnet both with IPv4 and IPv6 IP address. Okay, so we enable these 2. And for the IPv4, the subnet mask will be 24, and you are going to define the start value of IPv4. For example, if we input the 24 here, 24.0, and because that we defined the subnet quantity to 2, so the AC 3.0 will automatically assign 2 IP subnets. One is 24.0. The second will be 25.0. Okay, so the AC 3.0 will calculate the IP subnet by itself. And the same with the IPv6 subnet mask and the IP address. And for the VLAN type, we are going to choose the dynamic VLAN. And the start value of the VLAN, follow the guide. which will be 2001. Okay, you input here and click OK. And the system will automatically assign to VLAN to IP subnet here. Okay, IP address here. And will enable the DHCP relay by default on the VLAN interface. This is the IP subnet. And the last part will be the user access. You must define for the OA virtual network, where can the user access the OA network. Okay. In this case, we will let the OA user, for example, the sales user and guest user access the virtual network from A access or B access, or through the wireless way. Okay, so let's see how we can configure this. You can click the Create button and choose Site A, and under Site A you can see A access and B access. Okay, we choose A access and we choose all of the interfaces of A access. Then we click B access and we choose all of the interface of B access. Then, okay, and for that we have finished the wired access. And for the wireless access, because that the guest will access the network using the wireless way, so we must configure the wireless access here, and we will choose the site A, and we will choose the B edge, and the B edge will be the WLAN AC, WLAN AC of the network. We choose the B edge, and the same to the RD network. For you have to click the Create VN and follow the information here for the R&D to create another virtual network. And for the third one, IoT virtual network, you also need to create a new one and follow the information here. Okay. This is the creation of the whole 3 different virtual networks. And for the RD, you can see that the RD, we just have the research users to access the RD virtual network from the wild way. Okay, so for the user access, we just define the wild access. Okay, wild access. We will choose the A access ports and B access ports. Okay, and for the IoT, these virtual networks, we have the printer. Okay, we have the printer access to this virtual network. So, and for the wild access, we will define A access and the B access without the wireless access. Only OA virtual network has the wireless access. And we will also configure the mutual access between different virtual networks, for example, the OA and RD. And as I just mentioned, one virtual network is separated from another totally. So different users from different virtual networks cannot communicate with each other by default. And in some of the cases, we may want the user from one virtual network communicates with another IP subnet in another virtual network. Okay, so under this case, if the communication is allowed inside of the fabric, So we can we can finish the configuration very easily on the AC 3.0. For example, in this case, we want the sales user to communicate with the research user. They are in different virtual network, okay, and by default, they cannot communicate with each other. But if we want them to communicate, we must finish the mutual access configuration. So let's go to the provision logic network, and you can see we have a little button here, VN interwork. Okay, click this one, and I have already defined a policy. Okay, you can see that how I define this. From sales to research, this name can be user defined. Okay, and for the interworking mode, you can choose full interwork or partial interwork. Okay, in this case, I choose this one, and you can choose the IP address type, IPv4 or and IPv6, and the source VN will be OA, and the source IP address segment will be this one, and the destination VN will be RND, and the destination IPv4 and IPv6 IP address or IP subnet will be this, and click apply. The configuration will be downloaded to the border from AC 3.0, okay, so that the sales can communicate with the research. This is the configuration for interwork with different virtual networks. Let's go to the next step. In the next step, we are going to configure the wireless service on BEdge. In this scenario, we are going to use the native AC function of BEdge. The so-called native AC means that we are going to use the switch to perform the function of WLAN AC so that the switch can be used to manage all of the APs in the network, in the campus network. So in this topology, we are going to use the native AC function of BEdge. And as you can see that we have one AP here. So this AP's configuration can be downloaded from BEdge, and the AP itself can be managed by BEdge. Okay, in order to do this, we must log in into the portal of BEdge so that we can configure the wireless service on BEdge. Let's go to the AC 3.0 and click Devices Management. You can see all of the devices in the campus here. Let's choose BEdge switch, click, and this is the user graphic of BEdge. You can see we got the summary information, events log, and so on. Let's click this one, Open Web System, so that we can jump to the web system of BEdge. The system will open the window for us, and we must input the username and password for management. The username and the password, you can find the information here. Okay. Let's log in to the web system. Because that we are going to configure the wireless, so we click the configuration. And you can see we have several different menus under wireless services. Let's choose profile. First, we are going to configure the SSID profile, and we are going to associate the SSID profile with a VAP profile. And finally, we're gonna use this VAP profile to associate with the AP, or AP groups. Choose wireless service and find the SSID profile here. After you go to this interface, we can click the Create button to create a new SSID profile by ourselves. And for now, I have already created one named AG3. So let's go to see what I have configured. And in AG3, the SSID profile, I define the name of the SSID. SSID means that after the SSID works, we can log into the host for which will be a wireless termination, and we can see this SSID in our SSID list. Okay, so this is the name of the SSID, and for other parameters can keep default. Okay, this is the SSID profile, and by the way, you can also follow the parameters in data planning documentation. So this is the name of the SSID profile. This is the name of the SSID. After the SSID profile is done, let's go to the VAP profile and click VAP profile. You can use the button create to create a new VAP profile by yourself. And you also can use the default VAP profile. Let's go to the VAP profile that I have already created. Okay, VAP profile, VAP1. And in this graphic, you can see I defined the service VLAN ID here, just according to the data in data planning. You can see the service VLAN here 2001. I also changed the forwarding mode into tunnel mode. This is very important. Okay, so just follow the guide. And this is all of the configuration for the VAP profile. Let's remember two very important parameters. One is the service VLAN ID, and the second will be the forwarding mode. Okay, this is a VAP profile. We have created a new one which will named VAP1. Finally, let's open VAP1 and go to SSID profile. Let's choose the SSID profile that you have just defined, AG3. Okay, choose it here, and you can see all of the configuration from AG3. And let's go to authentication profile. And in authentication profile, you can click this button to choose the authentication template. Let's choose portal, which is created by myself. You remember that when we in the first or second module, we have already configured the template management, and we have already configured the authentication template, the portal. Do you remember that? And we have assigned the portal authentication template into B-Edge. So we can find the authentication template I have already defined here. So I'm gonna choose this one, click OK, and you can see we have associated authentication template with VAP1. That's all the configuration that we need to do. Okay. The final step is that we can go to the AP config. Let's find the AP. There are two ways to associate the VAP profile with the APs. The first way is that you can go to the AP config, associate AP with the VAP profile. This is the first way. And for the second way, because all of the APs is added into default group by default, so we can associate the VAP profile, VAP1, with the default AP group, so that all of the AP in the default group can be associated with the VAP profile, so that it can get the configuration from native AC. So let's use the second way. We can click the default AP group, and we can choose the VAP configuration. And by default, there will be no VAP template chosen here. So we can use the edit here and choose the VAP profile here. Okay, and for the VLAN ID, you can use 1 to define it. So finally, we have already created a SSID profile, and we associate the SSID profile with the VAP profile. We define the VAP profile, and we also associate the VAP profile with the default AP group. After that, the AP can be registered with the BEdge and the download configuration from BEdge. Well, let's go to the step 2.5. And in this step, I'm going to configure the XMPP service on A-Edge and B-Edge. That's because I'm going to use these two switches to perform the policy execution point. That means when the data goes through A-Edge or B-Edge, these two switches will check the, for example, source IP address and the destinating IP address to find out the source group and the destination group. This is a very important mechanism of free mobility. Okay, all of the switch will maintain a local table containing the communication metric that download from AC 1.0. Well, and for the switch, for the policy execution point, they must use the XMPP to communicate with AC 1.0. So that's why we need config the XMPP service on A-Edge and B-Edge. Let's go to the environments. This is our topology, and when you move over your mouse to the switches, you can see the login button. And for this step, we must configure A-Edge and B-Edge. So let's open the security CRT. You can click the login button here, and you can see the devices list on the left. Double click A-Edge, input the username and password. Well, this is A-Edge, and username, password. This is B-Edge. Okay, first, as we know that for our devices, let's take A-Edge for example. For A-Edge, AC 3.0, I mean the controller will create a very specific loopback interface for A-Edge and B-Edge. Well, loopback interface, and will assign an IP address to this loopback interface, and the switch will use the loopback interface to communicate with AC 1.0 through XMPP protocol. Okay, and the controller will bind this interface to a VPN instance or an VRF. Okay, so first we must find out which VPN instance is the interface binding to. So let's go to take A-Edge for example, and use the display current configuration interface loopback 2, and this loopback 2 is created by AC 3.0 controller, and this loopback interface is used to communicate with AC 1.0. And as you can see that this interface has already been binded to an VPN instance, and this is the VPN instance name. Okay, let's copy this name, and you can follow the step described in our demo cases Word documentation. Next, we are going to use this command to configure the XMPP service. As you can see, we are going to use the group policy controller and this is the IP address of AC 1.0, and the password, this is the password that we have already defined on AC 1.0. So both A edge and B edge, you can all use this key or this password. And the source IP address will be this one, okay? And for the VPN instance name, you must use this one, okay? So let's try this. System view, and go to group policy, controller. This is IP address of controller. And the password. And also the source IP address. Let's copy this one. And the VPN instance, let's copy this one. Okay, this is the command that we need to configure on A edge. And for the B edge, use the same way. First, check the configuration of loopback interface 2, and you can get the IP address, you can get the name of VPN instance that bind to loopback interface 2, okay, and just use the command here, but you need to check the IP address and the VPN instance name, okay, just one command. And after that, we have XMPP service enabled on A edge and B edge. Okay, don't forget, you must configure both on A edge and B edge.